Good afternoon again. So let's get started. We will look at the hello.c program which we discussed in the last lecture. We just looked at the program. We didn't do anything with it. So this is the hello.c program. So let's try to understand the syntax of the C program. So let's try to understand the syntax of the C program, and then we will build upon this. You're all good now? No disturbance, right? I muted everyone. So line 1 of this program, you can see this is what is called as a C preprocessor directive. This is called as preprocessor directive. Anything which starts with this hash symbol, you know, it is that statement, any statement which starts with the hash symbol, it is called as a preprocessor directive. And it will be processed by a program called as CPP. It is not comment. It is a comment in a Python programming language, but not in C. In C, it means it's a preprocessor directive processed by a program called as CPP, C preprocessor. We will see the purpose of it. What is the purpose of this and all? But if you take any arbitrary C program, a C program, it is a collection of functions. It's a collection of functions. A C program is a collection of functions, and every function, if you look at any function, the format of a function, it will be like this: return type, followed by function name, followed by parameters, and then some sequence of statements. So every function will look like this, that it will have a return type, function name, and within a parenthesis parameters, list of parameters, and sequence of statements. So here in this program, we have only one function, and the name of that function is main. The name of the function is main, and so this function main is a special, it is a special function, because when you execute a program, the operating system looks for the main function. So the operating system looks for the function main, and it calls the function main. And the program starts executing from the first statement of the function main. The first statement of the function main is the printf statement on line 5. And in this particular example, that is the only statement that is there in this program. And what is the return type of the function main? It is void. We are not returning the function main. It is not returning anything. And also there are no parameters to function main. So we can put in that void in between, or we can leave it as it is. We can leave it as it is. So this is the structure of a C program. A C program is a collection of functions. Among those functions, the function main is an important function. It's a special function, because when we execute a program, the execution of the program starts from the first statement of the function main. So we can write no main without, there are no parameters. The return type of main is it is void. That means it's not returning any value, and there are no parameters to main. So we put void, or we cannot have anything. So an alternate way of writing this, I'm just putting it. No? So you can even have void main. This both are what we have on line number 3 and what we have on line number 5. It is the same. Line number 3 and line number 5, they are equivalent statements. And line number 3, I use 2 forward slashes, meaning comment. The compiler, it ignores whatever that is there on line number 3 after it looks at the 2 forward slashes. So this is the comment. Green color erases in comments. Aman Raj. Thank you. So statement on line number 3, the line 3 and line 5 are both equivalent to each other. And so let's call this as version 1 of the program. So this is alternate way of writing this is when we have line number 5, it is also a comment. When we start with slash, so this one, this is the beginning of the comment, and this is the end of the comment. And every statement, it ends with a semicolon. So here we have the printf statement, and printf statement, it's actually a function call. We are calling a function, and we are calling printf. We are passing to the printf statement a parameter. That parameter is a string, and printf will print that string on the screen. And in order to use the printf statement, we need to have the include statement, include stdio.h on line number 1. Printf is a function whose code is already defined elsewhere. Printf function, it is part of what is called as a standard C library. You don't need to write code for printf. It is already written somewhere. It is already written somewhere. So here I want you to understand, this is what we are doing here. It is what is called as a function definition. Printf function is defined elsewhere. We are just using it now on line number 8. The return type of printf is not void, guys. Hold on. Okay. On line number 6, we are defining the function main, but on line number 8, we are not defining printf. We are calling printf, and printf is defined elsewhere. It is part of the standard C library. And in order to use that, we have to use the include statement on line number 1, include stdio.h. Printf is strictly not in stdio.h, but yeah. Are you all with me here till so far? See, I want to explain one thing. So, you may have some questions, note them down. If I don't answer, I may or may not answer your questions. But as the course progresses, you will understand, you'll get answers to those questions. You'll get answers to those questions. And if you still don't get answers to your questions, you can ask me. So just focus on what I'm telling. So an alternate way of writing this function is int main. So printf hello /n. And every statement should end with a semicolon. And here the return type of the function main is integer. So we put a return statement at the end of the function saying return 1. So even if you don't put the return statement, what happens is by default, some value will be returned. So what you are seeing from line number 17 to line number 24, this is an alternate way of writing this program where the return value of the function main is integer, and we use the return 1 or return 0, some value to return to the operating system which is calling this program. You can see on line number 22 a return statement. Later on you will see the return value for the main function is not a big, it's not usually, it's not a concern. In some cases we have to worry, but otherwise it's not of concern for us. So we can either use a void or int. Void means you are not returning anything. Whoever calls the function main is called by the operating system. It gets some status code from the program which it invoked. So what I would say is hold on to the return statement, don't worry about it for the time being, because when we write slightly more involved example program, maybe a couple of classes later, the purpose of return statement becomes clear. For the time being, all I want you to understand is this, okay? Either you can have a void return type for main, okay, as we are doing from line number 6 to line number 9. The second possibility is have a int return type for main and have on line number 22 a return statement. Just take it as a rule, okay? Just take it as a rule, and later on you will see, understand the meaning of this. Okay, so just take it as a rule. I'm not going to get further into this. Okay, two possibilities. Abstract, if you don't understand something, make a note of it and then you will understand it in some time. The first possibility is void. So you can see, since there is a void, you don't have anything at the end of the function main. This is possibility 1. Second possibility is you have an int and you have return 1 here. So this is second possibility. Remember, these two both are valid. Do you understand possibility 1 and possibility 2? I just want you to understand this, just as a rule. I know you are all curious and you want to understand why it is the case, but hold on to those questions, you will get your answers. Okay. Great. And the printf statement. So printf statement, it prints onto the screen. It's what is called as a function. So now we will write a slightly more involved example. Okay. So the problem that we want to solve is this. We want to compute the absolute value. Mathematically speaking, how is ABS defined? Absolute value of an integer A, it is equal to A if A is greater than or equal to 0, and if it is equal to minus A if A is less than 0. This is absolute value of A. This is what it is. So now we want to write a program for absolute value of A. That's our goal. So let's see. So control S, CP. Yeah, so you need to give good spacing between the lines. So we are writing our first program, the second program, void main. So this is the template code. For the next couple of classes, you know, when you start writing your code, you can start this way. Have this template ready. And the main function, it has return type void, and there are no parameters to it. So if you want to keep void, you can keep void. It's up to you. And then it starts with a left parenthesis and not left parenthesis, left flower bracket and right flower bracket. This is the basic boilerplate code. And what do we want to do? Our abs.c program. So expectation is takes as input some integer and it returns a if a is greater than or equal to 0, and it returns minus a if a is less than 0. This is what it is. So the first thing that we do is very important. So we declare a variable called as a. We declare two variables. One variable is a. The other variable is abs underscore a. This is called as, what we are seeing on line number 5 is called as a variable declaration. This is called as a variable declaration statement. Variable declaration statement. So what it says is this variable declaration statement, the effect of this variable declaration statement is when you execute a program, when you execute this program, the two variables a and b, they are allocated 4 bytes of memory in the RAM. So this is your RAM. These two variables are allocated so this is byte 10, 11, 12, 13, 14, 15, 16, 17. So these 4 bytes are allocated to variable a, and these 4 bytes are allocated to the variable abs underscore a. And both these variables, they hold, we will see why 4 we will, this is all happening in the RAM later, not in today's class. So these 4 bytes, variable is a is allocated 4 bytes and variable b is abs underscore a is allocated 4 bytes. And what is the address of the variable a in the memory? It is 10. The address of the variable abs underscore in the memory is 14. Are you all with me till this point? That as a result of the variable declaration statement on line number 5, when you execute the program, memory is allocated, 4 bytes of memory is allocated to variable a, and 4 bytes of memory is allocated to variable abs underscore a. So yeah, the address of variable a is 10 in this hypothetical example, and the address of abs underscore a is 14 in this, again in this hypothetical example. So this is important, this and this. Both these are variables. So now we want to first prompt the user with enter the value of a. This is the next. Enter a value. is what we prompt. So we on line number 7, so we have this printf statement. This is what is called as a function call. This is a function call statement. This is a function call statement. Printf is defined elsewhere. We are calling that function printf. We don't need to write code for printf. It is part of the standard C library. And then, so we want to use scanf. So maybe it's a good idea to even write comments. So like, for example, here you can have something like prompt for input. And you can say read input from the keyboard. Read input from keyboard. Hold on. So there are some questions from Mayank. I'll answer your question later. It's an important question. And we use the way scanf has two parameters, %d and ampersand a. So scanf is a function call. To scanf, we pass two parameters. The first parameter is this string, and the second parameter is ampersand underscore a. What is ampersand underscore a? So this is what is called as an address operator, address of operator. What it returns is it returns 10 because the address of the variable a is 10. So to the scanf statement, we pass the string and we pass the address of the variable 10. And what happens is when scanf looks at the string, when it looks at this %d, whatever the input that is present given at the keyboard, it interprets it as an integer, and the value of that integer, it will write into the memory location whose address starts from 10. Okay, remember, if it's an integer, 4 bytes are allocated, 10, 11, 12, 13. In those 4 bytes, that sequence of 4 bytes are allocated to variable a, and the value that is read from the keyboard, the integer value is assigned to the memory location associated with variable a. This is all in RAM. %d is very simple. %d tells scanf that we are trying to read an integer from the keyboard. Scanf has two parts to it. One is %d, the string tells, in the string you see %d, and all it tells is that we are telling scanf to read an integer from the keyboard. Are you with me there? Very simple. %d means we are telling scanf, hey, that we are trying to read an integer from the keyboard. %d is a convention. It's part of standard C library, but it's a convention. Whatever the integer that is read, where should it store? Where should we store? Integer that is read from the keyboard, where should we store? It should be stored in the RAM at the memory location associated with variable a. At the RAM, in the RAM at the memory location associated with variable a. And that is why we are passing the address of the variable a by using this ampersand operator. Ampersand is address of the variable a. That's what it means. Are you with me here on the scanf statement? Just think of %d as a convention for the time being. %d tells the scanf statement that we are trying to read an integer from the keyboard. And not only that, whatever the integer that is read from the keyboard, we want to store it in the memory location associated with variable a. And how do you get the memory location associated with variable a? By taking, so a means whatever the contents of that thing, and ampersand A is the address of A, which is nothing but 10. All right. So now we have read the input. So now I'm introducing a new statement. So some of you were asking about what is a control transfer statement. If is a control transfer statement, so we say if A is greater than or equal to 0, if A is greater than or equal to 0, so if is what is called as a keyword. Okay, so if statement, if is a if statement, if A is greater than or equal to 0, we have to put this condition within parentheses. The condition A is greater than or equal to 0, we have to put it in parentheses. This greater than or equal to is what is called as a relational operator. And then, so if this condition is true, then what we do is, then the absolute value of A is equal to A. So what happens is the contents of the variable A is copied as it is to ABS underscore. Are you with me here? If the condition is true, the contents of the variable A, if A is equal to 10, after statement 13 gets executed, ABS underscore A also contains 10. If this condition is false, else, if this condition is false, so this flower bracket we can use, put it here also. Let's use this convention. Yeah. So what should be the statement on line 18? ABS underscore A is equal to minus A. So we take read the value of A and then we negate it. So if A is equal to minus 10, then what happens is condition at line 12 will be false, and we go to the else part, and minus 10, minus of minus 10 becomes equal to 10, and 10 will be assigned to ABS underscore. We don't need a semicolon at line number 19. We don't need a semicolon. Yeah. So this is the, so now, are you all fine with the if statement? Cool. So now we have computed. So we print again. In the case of print, so we have to specify the format specifier. So what we do is, I'll first write down the statement. So here what happens is, pay attention. So printf keeps printing whatever that is there in the string that is passed here. This is the string. The first parameter to printf is a string, right? So it prints every character that is present in the string, but when it hits this %d, it is a placeholder. So what it does is it goes and tries to find the first parameter after the string and associates it with this %d. This is number one, first association. And then again it keeps on printing, and when it looks at the second %d, it goes and finds the second variable that is coming after the string, and then it replaces this %d with whatever ABS underscore A is. All right. ABS underscore A is just the name of a variable. So this association that printf keeps on printing this string, But once it hits %d, it goes and looks at the first variable and replaces this %d with that value. And similarly, the %d here, no, it gets replaced with the value abs underscore. It is just a convention. So let me run the program here. Okay, so let's run the program. CD CP21B GCC abs.c. So since I did just let me redraw. See dot a dot out, and if I press enter, so let me use /n here so that the printing will be nice. I changed the program, so I am compiling the program again. So if I don't give any minus so abs or anything like this, I didn't give anything. In the absence of this, what happens is the executable will be generated in dot a dot out. So now, so what happens is, so if you look at the printf, it prints this first vertical bar, and then it looks at %d here. And when it looks at the %d is a placeholder. So it goes and looks at the value of the variable a. So variable a holds 10. So this %d is replaced by 10. And then after that, it prints the next vertical bar, space equal to blah. And then again, when it looks at the second %d, it goes and finds the value of abs underscore a, and it and then it replaces the %d with that value. So dot this when you, so in the file system, if you see remove a dot out, so there is this question when you compile this program. This is in Linux. When you compile this, the generated executable is there in a dot out. Okay, and when we say dot a dot out, we are telling the shell, hey, there is this program called as a dot out in the current directory. Execute it. So now dot a dot out and minus 10. What will be the value? What will happen in the screen? What will come on the screen? Complete output. Exact output. Yeah. Anusha got it. Nice. So you get vertical bar because vertical bar is here, that came first. After that %d is replaced with value of a, and a is minus 10. And after that, you print the whole of this market space. And then after that, you will see %d, but this %d is replaced with abs underscore a. And the value of abs underscore a is 10. So you replace it with 10 and then new line character, and this is what happens. Are you all with me here on this example? Are you good? Any questions? Okay, so let me, in the next 10 minutes, 15 minutes, we will not look at a new program. I'll answer questions related to this, some of the questions. The first question is, let me clear all the screen. Let me come out of this here. I have entered this program abs.c, and and that program is stored in the directory CP21B. Okay, so if I do ls minus al, you can see that abs.c program is present on this line. Okay, it is present on this file system. And then in order to run this program, we have to compile this program. So there are two ways of doing it. One is gcc abs.c -o abs. So the GCC compiler will translate the C language statements into a sequence of instructions which are understandable by the processor. Okay, and the ABS contains that. Okay, so now this is what we have seen. File abs.c, it is present on the hard disk. File abs, it is present on the hard disk. And you can see that abs contains instructions from the instruction set architecture whose name is x86-64. Are you all with me here? These 2 points. So abs.c is present on the hard disk. Abs is present on the hard disk. So the memory for the variables, if you go to the program, the memory for the variables abs underscore a, they are not allocated. Okay, it's not there. But now when you give the program abs for execution, ./abs means in the current, you're telling the bash shell, this is a terminal. What I have is what is called as a bash shell. I'm telling the shell that I want to execute a program whose name is abs and it is present in the current directory. Dot means current directory. ./ means in the current directory, there's an executable file called as abs. I would like you to execute, I would like you to help me execute that program. Are you with me on this one? Why I am using ./abs? I am using bash shell. Okay, so I'm telling bash shell, please execute the program abs whose path is ./ dot means current directory. Dot means one directory level above. Like for example, if I do pwd, so the path is the home Purini CP21B is the path. Okay, is the path, and in this directory I have this file abs, executable file abs, and I would like you to execute this. So one way of doing it is /home /Purini /CP21B abs. This is one way of executing this. I'm giving the whole path, and then when I enter 10, it returns this. But a shorthand for this is ./abs, that is in the current directory, because already I am in the directory CP21B, so I don't need to give the whole path. I'll just give .abs and then say -10, it runs. Are you with me here on this one? So if I, instead of using the command gcc -o abs, if I just use gcc abs.c, then the executable file will be generated in a file called as a.out by default. So if I see file a.out, the executable file is now present in a.out by default. And if I run this program, so -12, then we'll get 2. So that's all. If I don't use -o abs or -o whatever it is, by default, the executable file will be returned to a.out. Are you with me? There's nothing there to explain there. So a dot out, instead of it will be generated in a file called as a dot out. That's all. The name of that file. If you don't give specifically where to put the generated executable, a dot out, it goes to a dot out. It's called as default. A dot out is an executable file. That's true. We can execute that program. How did you execute the program in? See, one important thing, there is this question. At this point in time, for the first 2-3 weeks, don't execute the programs in Visual Studio Code. I want you to be familiar with the terminal. Okay, come to the terminal, compile the program, run the program. If we compile another program, it will overwrite a dot out. Like for example, if I do gcc hello.c, okay, now if I execute a dot out, what do I get? If I execute, yeah, we get hello world. Nice. Okay, so this is about program compilation, execution, a dot out, and all these things are specific to Linux. Those of you who are in using Windows, I don't know how it works. Yeah, so as I said, I don't want you to use Visual Studio Code environment for some time, because you should know how to use the terminal, what is a dot out, what are directories, all these things becomes clear when you use the shell. What else? So great. Yeah, you can change the name of a dot out, it will still be executable. Bash shell, etc. I will do one thing, I will send you one set of video lecture links, you should watch them. Okay, maybe because there you'll understand what is bash shell and all. Now let's come back to the C program. What questions you have with respect to the C program here? It is possible to scan 2 variables at a time. Yeah. Yeah. So, or I want to take Aryan's question, are A and ABS underscore A stored in next to each other in RAM? It may or may not be. They may or may not be. So in the next 10 minutes, I will just rewrite, review what we discussed, and then we will close today's session. First one is this program, how many functions are there in this program? There is only one function. No, there are no 3. We are defining only one function in this program. No, there are no 5. There is only one function. There is only one function definition. Only one function definition. And what is that function? That function is main. Just follow along with me, okay? What is the return type of the function main? Void. It is not returning any value, it is void. Is function main taking any parameters? It is not taking any parameters. And what are the two functions which the main function is using or calling? Printf and scanf, not if then else. If and else, they are not functions. So printf and scanf are the functions which the main function is calling. Where are they defined? Where are they defined? They are not defined in stdio.h. They are defined in standard C library. They are defined in standard C library. But in order to use printf and scanf, what should we include? What statement should we use? Line number 1, include stdio.h. In order to use printf and scanf, we need to include, we need to have stdio.h. Are you all with me here till this point? Okay. Now, line number 5, we are declaring two variables. One variable is A, and the name of one variable is A. The name of the other variable is abs underscore A. All right. How many bytes are allocated to each of these two variables? 4 bytes. Now, on line number 7, we are calling the printf function. How many parameters we are passing to printf? We are passing only one parameter, and that parameter, no, it is of type string. Okay, it's a string parameter on line number 7. What will printf do? In this particular case, on line number 7, it prints the string onto the screen as it is. Great. We keep the string parameter, no, it just takes a string. Don't worry about it. It just takes a string and it prints it onto the screen. So now let's come to line number 9. In line number 9, we are using, on line number 6 and 8, we are using a commenting technique. What is the commenting technique that we are using? Yeah, forward slash. Good. Single line comment. This is a single line comment technique. For block, we use a different. How do we put block here? Argya has got it. Great. Nice. You're all with me. Now let's, on line number 9, we have a scanf statement. How many parameters are there to scanf statement? There are 2 parameters to scanf statement. So the %d in the first parameter, what does it tell scanf? That we are trying to read an integer from the keyboard. Whatever the value that is, the integer that is read from the keyboard, scanf has to assign it to someone, has to put it in some memory. In which memory location it will keep? The memory that is associated with variable A. And ampersand A gives that address. Ampersand A gives the address of the variable A. Okay, let's say if in the memory, this is what we have seen. This is hypothetically speaking. What if I don't use, try it out and see what happens, Anaika. So this is 10. So then what happens is the address of the variable 10 is passed here, and in that memory location, the value 10 will be, to that memory location, the integer that is read from the keyboard will be assigned. Okay. Are you all with me on line number 9? Just as it is, no variants. What I have written, you understand. So, great. Now come to line number 12. If A is greater than or equal to 0, if A is greater than or equal to 0, then what happens? So if A is a positive number, then the condition will be true. Then we go to line number 14. And on line number 14, what happens? What is the statement called as line number 14? the contents of A gets copied to contents of the other variable abs underscore A. This is what is called as an assignment statement. On the contrary, if this is false, then control will go to line number 18 and minus A. If A is equal to minus 10, minus of minus 10 is 10, and that 10 will be assigned to abs underscore A. That is what happens on line number 18. And then on line number 21, what happens? Line number 21 is a printf statement. And so how many parameters are there to printf? 3 parameters, 3. And the first parameter, what is the first %d called as? Placeholder. This is the first placeholder. This is the second placeholder. So what will 1 be replaced with? Placeholder 1 is replaced with what? Value of A. Placeholder 2 is replaced with what? Value of abs underscore A. And that is what will be printed on the screen. And that is the summary of this program. Are you all with me here on this program completely? Okay. Awesome. So if this much is clear, then I can take other questions. Okay, I'm happy if you are clear with these ideas. These ideas are essential. So try it out, Arya. So it's int means input. No, int means integer. So Purvi, this okay. Gaurav is desperate to talk. You have to be patient, guys. There is a flow that is going, and you continuously keep saying unmute, unmute. I don't know whether my speaker works. Let's try.
Hello.
Yeah, go ahead, Gaurav.
Good afternoon.
Who is this? I am not able to hear. Who is? The 3 parameters on line 21. The first parameter is the string, second parameter is A, and the third parameter is abs underscore A. Okay, so you have few questions. I think I will take those questions in the next class. But I just want to, yeah, you can use any other variable. No, we can name it as arbitrary. What do you mean by that, Gaurav? If you write an integer anywhere on the program, will still. On line number 12, you don't need a semicolon, Meghna. The format of the if statement is this. Pay attention. So we use an expression here. So this is the format of the if statement. You don't need. Yeah. So there is this question. If there is only one statement, can you skip this? You can skip it here. All right. So I think I will stop today's lecture here. Just want to check. I know, as I told at the beginning of the lecture, I will not answer all your questions. I may or may not answer your questions, but everything will be clarified in course of time. Okay. So, and if your questions are not answered, I will definitely take them up. But all your questions will go in detail. Because in order to give a proper answer to some of the questions, I have to go in a different direction. So that's why I hold back. And so 6:30 p.m. it's not class. Okay, those are tutorial. These are TA hours. Those of you who have some problem or other, you can drop in and ask questions. Please read the textbook, and I will also post one more book called as Essential C. It's good to read the book because many of the details which we cannot discuss in the class, they will be discussed in the book.